is to define the variables. And we're just going to use X and Y to keep it consistent. The X is the first part that they talked about, the first object. Well, that was adults. So whatever comes first, let's call that X. The second part of the question or the statement here said students. So that's what we're trying to figure out, adults and students. So the second one we're going to call Y. So that should be an easy part. Whatever's first in the sentence is X, whatever's second in the sentence is Y. Part B, write a system of equations. So this is where we need a money equation, and then we need an equation dealing with how many tickets were bought. So if you look through the question, an adult ticket costs $15. That's money. A student ticket cost $10, more money. We paid $175 for all the tickets. So all of that money needs to go in the same equation. Michael, do you think you can pull those three pieces together and make an equation?
I did 15x plus 10y equals 175.
Awesome. Perfect. So that's our first equation. $15 for the X, $10 for Y, 175 bucks. The second equation is the number of people or tickets that we're dealing with, and it's 15 total people. So my total is 15. The types of people that are going are adults and students. So adults, X, plus students, Y equals the total of 15. So that's how I would create my two equations. Now the third part says to solve. These two equations is what we've been working on the last 3 weeks. We can solve using substitution. We can solve using elimination. But the last 3 weeks, you were given the equations. Now we actually created them. So that's like the new part. Let's use elimination because I think elimination is easy to use. Let's multiply by something. Doesn't matter what. Let's say we'll multiply. Let's eliminate the Y variable. So if I have a 10 here, I want to multiply by a negative 10 so I can get my Y's to cancel out. And I just picked the one that was smaller. It's easier to multiply by 10 than it is to multiply by 15. That's why I was going for the ease factor here. So the first equation stays the same. The second equation, we're multiplying everything by negative 10. So negative 10x, negative 10y equals negative 150. So this is that elimination. So Haley, if we add these together, what is 15 minus 10?
5x.
Perfect. What happens with the 10y minus 10y?
They cancel.
And then do you know what 175 minus 150 leaves you with?
25.
Awesome. The last step, divide by 5. Haley, what is 25 divided by 5?
5.
Perfect. Not so bad. So here's one answer. I have a 5. X equals 5. We know with these equations, once you find one answer, you need to find the other. Our goal is to figure out how many adults and students went to the play. So this X represents my adults. We are trying to find the students. Use the easy equation. X plus Y equals 15 because I want to know how many students went. And if I subtract 5, I get Y equals 10. So instead of writing this as an ordered pair, we need to actually answer the question. How many adults? Well, X is adults, so there were 5 adults. Y is the students, so there were 10 students. That's the final answer to our question. 5 adults and 10 students went to the play. Any questions on number 3? All right, I want to start number 4 as well. This one was similar to one of the notes that we did yesterday. Yesterday we had a guy named Rob. Today we have Kelly, and Kelly has 24 dimes and quarters. So again, right away, define your variables. Whatever is first goes with X. The second thing goes with Y. So X is dimes, Y is quarters. We're going to write an equation for money, and then we're going to write an equation for coins. Now this one's a little tricky because you have to think about how much money is a dime worth. I know I have a total of $3.60. A dime is 10 cents, but we have to talk about that as a dollar amount. So it's 10 cents on the dollar, 0.10. A quarter is 25 cents or 0.25. So I can't keep that as 10 because 10 would mean $10 since we're comparing dollars here. So Bill, how could we write our equation for the money equation?
Point 10x plus 0.25y equals 360.
Nice job. So that's how much money we have. 10 cents for the dimes, 25 cents for the quarters. We have a total of 360. The second equation always goes with how many things you have, how many tickets I sold, how many coins I have. Well, we have 24 dimes and quarters. So dimes and quarters means X plus Y. And then that's equal to 24 because that's how many I have in my pile. I am not going to solve this one with you because I want to do 2 more problems in the notes, but this is how you would set it up. And then you can solve it using substitution or elimination. Questions? So I want to go over 2 more problems in the notes today. And then pretty much similar, same types of problems. It's just you feeling comfortable about trying to write the equations and solve these equations. So you have 2 problems almost done. Mr. King yesterday did number 1. So if you look at the notes or the video from yesterday, you'll see number 1 done. And 3 is done and 4 is almost done. So you shouldn't have much more to finish with this homework. Again, the important part is getting some points, practicing a couple of problems, and then don't forget to submit these problems. So I'd like you to take out the application packet that we've been working on. Here's that dimes and quarters that we did yesterday. And yesterday we did a talent show instead of a play. So we have 2 more examples. This is on page 8. And if you don't have these printed out, you don't want to use Notability, just write them down on a piece of paper. So this is section or applications of systems, and this is day 2. So we're going to try and do the same exact thing. Judy worked 8 hours and Ben worked 10 hours. Their combined pay was $80. When Judy worked 9 hours and Ben worked 5 hours, their combined pay was $65. Find the hourly rate for each person. So we want to know, how much did they make per hour? What were they getting paid per hour? So just like we've been doing, the first thing that you read is Judy. So I'm going to make Judy X. But it's her pay per hour. That's what the X actually represents. How much is she making per hour? The second person that we read says Ben. So Ben would be Y. And it's her pay or his pay per hour. Now, this set of equations is a little different than all of the other ones that we've done. If I look at these two sentences together, Judy worked 8 hours and Ben worked 10 hours. Their combined pay was $80. The total combined for the two of them is $80. So that has to go on the other side. Anytime we see a combined amount or a total amount, that goes on the other side. Judy worked 8 hours, but I don't know what her pay is. But to find it, I would take 8 hours times the amount of money she made. Ben worked 10 hours. Again, I don't know how much he gets paid per hour. But to find that, I would take 10 times y. So my first equation says 8x plus 10y equals 80. Let's look at the second sentence. Actually, I guess it's the third sentence. See if you can write an equation for that sentence. Judy works 9 hours and Ben works 5 hours. Their combined pay is $65. Try and write it the same exact way as the first. Nakai, how do you think we could write that equation using the same way we wrote the first equation? So trying to model what you did for the first equation, Nakai, how do you think we could write our second equation? Michael, do you think you could help out? How could we write the second equation?
I did 9x plus 5y equals 65.
Yeah. So Michael, if you look at these two equations, how do you think we could use elimination? So what could we do to use elimination? And let's eliminate the y's. What could we multiply the second equation by so we could eliminate the y's?
-2.
Awesome. -2. Elimination usually works pretty nicely for these problems here. So the first equation stays the same. And then the second equation, we're going to multiply everything by -2. So -18, -10, and -130. Michael, when we combine the x's, what do we get?
-10.
What happens with the y's?
You get -50.
Yeah, nice job. And then when you divide here, Michael, what do you get for x?
You get 5.
X equals 5. Nice. All right, let's see if we can find y. So if x is 5, go back into one of your equations and let's plug that in. So 8 times 5 plus 10y equals 80. I'm using just this first equation here, trying to find y if x is 5. 40 and I subtract 40 to the other side. So 10y equals 40 and then divide by 10. Okay, so let's answer this question. We found the x and the y. It says find the hourly rate of pay for each person. So x, is Judy's pay per hour. That means Judy made $5 per hour. The Y is Ben's pay per hour. He made $4 per hour. Do you think you would have this job if you only made $5 or $4 an hour? Bill, I know you
No.
work. Bill, would you take a job for only making $5 an hour?
No.
Not unless you got tips, right? Maybe if you got tips, it wouldn't be so bad.
Yeah.
Do you know what the minimum wage is per hour, Bill? In the country?
It's like averaged out to like $9, I think.
Yeah, something like that. So I don't know what these kids are doing, but they're not working at the right place. So let's hope they get some kind of tips on top of this. Otherwise, I'd find a new job. Any questions? Good. I think I need to change my numbers, make it a little more. I made $5.15 at my first job, and I worked as a cashier at a grocery store. And that was in 1996. $5.50 or 15 cents is what I started out with. 1996 as a cashier. And I think the most I made, I worked there for a while. I might have made eventually like $7 an hour, maybe, as a cashier. I got little raises every once in a while. Usually that's how it works. You work at a place for a little while, they give you a raise. All right, the last question here. Pets. So we have a pet store. Dogs and cats. Does anybody have any little pets running around in their house right now?
Many.
Many?
Yeah.
How many do you have, Michael?
I have 2 dogs, and my dad's getting my mom a puppy for Christmas. So there's about to be 3.
Oh my God.
And we sometimes have a bunny running around because of
Oh,
my
you have
sister.
a bunny too? I have a bunny.
Yeah,
Does your bunny chew cords?
it tries to. Yeah,
Ours too. Yeah.
yeah. So we just like to keep him in the cage,
Yeah, that's what we
but
usually do too.
bring it out every once in a while when we can watch her.
Yeah. Our bunny's name is Ruby, and Ruby has to be monitored very closely. She also digs up
Yeah.
carpet. Like she'll take her little claws and like dig up like little pieces
Oh
of
yeah.
carpet. So Ruby lives in my younger daughter's room. She's in a cage in Sadie's room. They're best buddies. Nobody else likes Ruby except for Sadie. I think she's pretty nice, but she's got a little bit of an attitude. I think because she's a girl bunny. I guess I don't know. She has attitude issues. Not that girls ever have attitude issues. All right, so let's look at this pet store. So think about those wonderful pets. We have 2 cats and a bunny. That's what we have. So we are selling dogs for 140 bucks. That doesn't sound too bad, I guess. I know dogs can be really expensive. Cats for $70. If the pet store has 28 pets that were sold and their earnings were $3,360, how many dogs and cats were sold? So essentially, we want to know individually. Did I sell more cats than I sold dogs or vice versa? All right, first thing, XY. This should be the easy part. First thing in the question, dogs, make that X. Second part of the question, cats, make that Y. Sadie and I are allergic to dogs. That's why we have cats. And I get annoyed by the neighbors and the people in my neighborhood who leave their dog poop just in the middle of the road in a bag. Not a cool thing to do when you take your dog for a walk. Try and write the equation. So this one is like all of the others. We're going to have a money equation, and then we're going to have the total number of pets equation. So try and write that equation. 140 for dogs, 70 for cats, total. So 140 dogs, 70 cats, total 3,360. So try and look at the question and pull the numbers that are the same. All those have dollar symbols. So we're going to try and write an equation with the dollar symbols. The total is always on the other side. That's always the total. The second question, pets. How many pets did we sell? Well, 28 pets were sold. So again, that's my total. What types of pets did we sell? Dogs and cats, or in algebra, X and Y. So that's the tricky part. Now we're going to use elimination again. And I would look at the smaller of the two numbers. So notice that Y has a smaller number in front of it. I know these are big numbers to begin with, so we're going to need a calculator. If there's a 70 in front of Y and I want to eliminate Y, I need to multiply the second equation by negative 70. Again, the goal here is to try and use the smaller numbers. That's why I chose to kind of eliminate the Y. Might need a calculator here. So the first equation stays the same. The second equation distributing 70. Negative 70x, negative 70y, and then 3360 times 70. That's a big number. Oops, wrong number. How about 28 times 70? Whew. Negative 2660. That's what I got. That looks better. So 28 times negative 70. And then add. So 140 minus 70 is 70. X. Y's cancel. And then we have 300. Yes.
When I multiplied negative 70 by 28, I got negative 1,960.
Oh, thank you. I must have put in it. Yep. Thank you. Good
Problem.
catch. Negative 1960, right? Yeah. Thank you.
Yeah.
I don't know what I multiplied together. So when we take 3,360 and subtract 1,960, you get 1,400. That works out way better. So Michael, if you took 1,400 divided by 70, how many did you get?
20.
Yeah, 20. So the last part of the question here, take the equation. The easiest equation is x plus y equals 28. I now know x is 20. I don't know y. But if I subtract 20, I get 8. So Haley, how many cats and how many dogs did we buy? How many dogs were bought or sold?
20.
Yeah, 20 dogs. How many cats?
8 cats.
8 cats. So I guess people like cats better than dogs at this pet store. 20 dogs. It's like more than double the number of cats that were sold. Does anybody have questions? Hopefully you feel a little more comfortable working through these problems. We went through that one a lot quicker. So your homework is the same type of problem. So same type. And again, there's 4 questions. So I'm going to pull that assignment up so you can see what it looks like. Same type of questions. This first one looks like a big paragraph, but the second one, ooh, pizza party. We either have pizza every Friday or every Saturday. You got to have pizza once a week in my house. Looks like we have a hair salon and then a sporting goods store and golf bags. So very similar type of question. All I'm going to do is set up the first problem with you so that you can kind of get a head start. that you have won to model. Class president is organizing a trip to Kennywood, wonderful Kennywood. 314 students. That's probably very similar to the senior class this year. I would say there's probably right around like 315 kids in the class. The regular price at Kennywood, $35. I actually think this is a little more. Maybe this is like a discounted price. I want to say it might be a little more this year. Some students received a discount because they volunteered for community work. Those students who got the discount only paid $21.50. And if you remember, on a typical year, usually they have those discounted tickets that they sell in the athletic office as well for Kennywood. The total cost was $10,072. This one's a little tricky. So the X in this problem is a regular price. So X is our regular price ticket. And then there's a discounted price. So that's what we're comparing. How many regular price tickets, how many discounted tickets? That would be the X and the Y. Because we're not talking about students versus adults in this question. They're all students. Every student in the class is going on a class trip. So we have our regular price and then the discounted price. We want to write an equation first to represent money. So look at the money here. Show me the money. $35 for a regular ticket, $21.50 for a discounted ticket. The total amount of this trip, $10,072 for the class to go to Kennywood. I know they used to go to Cedar Point. Maybe sometime we'll get to have a class trip again. The second set of information, so that's our money, would be the number of people that went or the number of tickets that we have. And that is 312. So my regular price tickets, my discounted tickets, 314, not 312, 314 students. When I use elimination, I look at the number that would be easiest to multiply by. X is a whole number of 35. The Y has a decimal in front of it. So it's probably easier to multiply this equation by negative 35 so that I can eliminate the X. So keep the first equation the same. And notice I used elimination every single time. I think it's easier to use elimination, and that's just me personally. And then multiplying the negative 35 through. And I'm going to make sure that I multiply this one correctly this time. 314 times negative 35. So I'm going to leave this for you to finish. Now you have to get out that calculator and add the values together. So I'm just using my calculator, adding these values together, combining my like terms, and then dividing. And I got 68 for Y. After I find y, I need to get x by plugging in 68. So I would subtract 68. And I get 246. Does anyone have questions? So there's another problem done. Just don't forget to label. So this is 246 regular price. So 246 kids, they didn't do the extra community service. They didn't get the cheap price. Only 68 got the discounted version because they did community service. So you have one problem done. There are 3 more identical to this. There's still 5 minutes left in class, so feel free to stay on, ask questions. Otherwise, have a fantastic day. But please get these problems done. 3 problems to go. Have a good day.